Okay, today we're going to talk about the accumulation function, which is something that comes up very regularly in FRQs in the AP exam. So the accumulation function looks like this. It's the function g of x, and it's defined as the integral from 0 to x or from any other constant to x of f of t dt. Just make sure you notice how the variable here, t, is different from the variable up here. Once we integrate this in terms of t, we will then have to substitute x minus substitute 0, and we'll get a function in terms of x. So this looks really hard maybe and very abstract, but if we check a first example, we'll see what it actually means. So here g of x is the integral from 1 to x of 2t minus 3 dt. That's obviously the equation of a line, y equals 2t minus 3, which I represented here. So what does this function g represent? It actually gives us the area, or better, the signed area, between 1 and x. So typically, if we choose x equals 1 here, clearly that's the integral from 1 to 1. There is no area under the graph, so g of 1, if we pick x equals 1, is going to be 0. Here I have an x at a random place near 3.25, so g of 3.25 would actually give me the area, the signed area, sorry, from x equals 1 to x equals 3.25. Here's an example where I selected x equals 5, so if I need to find g of 5, x equals 5, therefore I substitute 5 everywhere, so the x I had up here becomes 5. Now this is a standard integral from 1 to 5 of 2t minus 3 dt. The integral of 2t minus 3 is t squared minus 3t, which according to the fundamental theorem of calculus is 5 squared minus 3 times 5 minus 1 squared minus 3 times 1. And in the end, I find 12. So if we go back to the original question, g of 5, the question is here, what is the signed area from 1 to 5? What is the integral from 1 to this number? So what does it look like in a real FRQ? I chose this FRQ from 2005. It's also the question we had in the worksheet 5.3 if you want to find it. And we'll work through all of these questions, A, B, C, D. We'll also see with another FRQ how some similar questions come up. And the more we'll do these kind of exercises with an accumulation function, the more you'll see the questions are very similar every time. So, first thing you notice, we have a geometric graph here. It's made of lines. That's very typical. Almost every time FRQ has an accumulation function, they also show you a graph. So the graph of the function f above consists of 3 line segments. It's not above, obviously, but it's here. So we have a line segment, a second line segment, a third line segment, and we define the function g as the integral from -4 to x of f of t dt. So if I repeat what I said earlier, this function g is actually giving me the integral from -4 to x. If I choose a given x, it's going to give me the area with a sign of the function from -4 to x. So question A is for each of g of -1, g prime of -1, g double prime of -1, find the value or state that it does not exist. Let's do g of -1. We saw an example just before. That's easy. X equals -1, so instead of x, I'm going to put -1. Every time things are written in red, it means I'm actually solving the question. And now, what is that? It's the area between the graph of f and the x-axis from -4 to -1. Let's go out of this slideshow for a second and see on a graph. This is the same graph. If I integrate from -4 to -1, I find this area here. It's a trapezoid. It's below the x-axis, which means the integral is going to be a negative number. But what I'm asked to do in this very first question is simply to find the area of this trapezoid. So this base is 3, this base here is 2, the height of the trapezoid is 3, so 3 plus 2 over 2 times 3, so big base plus small base over 2 times the height. And then you have to remember at some point to put this negative sign because the area we're looking for is below the x-axis. And that's -15 over 2. So we already solved g of -1. What about g prime of -1? Well, if g of x is this, then g prime of x is the derivative of that thing. And here we recognize what we studied a little bit later in chapter 5. We see that we have an integral and a derivative. We can look at the three conditions we have to make the transformation. So we have a constant here, it's good. We have a variable here, it's just x, so it's good. And we also notice the variable corresponds here and there, so we're good. We can say that this is actually simply f of x. So remember what you do in a case like this. You actually substitute x here for t, and therefore you just get f of x. So g prime of x is f of x. Now, what is g prime of -1? G prime of -1 is f of -1, clearly. And how can I find the answer? I need to look at the graph. This is the graph of f. So f of -1, I find -2. Last question, what is g double prime of -1? If g prime of x is f of x, then g double prime of x is f prime of x. I can differentiate both sides. And again, I can look at the graph. At -1, what is the slope of f at -1? Here's the graph of f. What is the slope at -1? The slope is undefined. The slope from the left here is different from the slope from the right. So f prime of -1 is undefined, which means g double prime of -1 is undefined. So if we have a look at this FRQ from 2012, we can see that question A, well, first of all, we can see it is exactly the same kind of thing. We have a geometric graph here with 3 line segments. We also have a semicircle, but that's also something we can calculate with geometry, just like triangles, rectangles, trapezoids, etc. And question A is find g of 2. Question B is find g prime of -3, find g double prime of -3, so very similar. One thing you want to notice here that's a little bit extra compared to the example we're studying together, g of -2, if you look at how g is defined, it's going to be the integral from 1 to -2. So since you're moving backward from 1 to -2, you're going from 1 to -2, you'll have to switch the sign of your answer. You can find the area from -2 to 1 and then change the sign. So back to our question, the graph we had earlier. Question B, for the function g defined earlier, find the x-coordinate of each point of inflection of the graph of g on the open interval from -4 to 3. Explain your reasoning. The points of inflections of g are places where g double prime changes sign. This is something you need to know. Point of inflection is when g double prime changes sign. G double prime, we saw, is f prime. So we can reformulate this sentence here. F prime changes sign. When does f prime change sign? typically when f prime equals 0, but also it can happen that f prime changes sign when f prime is undefined. So let's look at our graph of f. F prime means the slope. So if I'm going along the graph here, f prime is positive. Clearly the slope is positive. Here f prime is still positive, it's still positive. And then here f prime is suddenly negative. What happened at this point? At this point f prime is undefined. There's a sharp turn. So that's typically one of the candidates we have to identify. But more than that, just notice how the slope is positive and then the slope is negative. So we found where g has a point of inflection. It's at x equals 1. If we look at the FRQ from 2012 and you go to question D, you will notice that the question is find all values of x for which the graph of g has a point of inflection. Exactly the same question. Since we went through the thinking now, it's kind of easy to solve this question. We saw that it's when f prime changes sign, so the slope here is positive, here it's negative, suddenly from here on it's positive again, and then it's negative. So in this exercise from 2012, there were many answers. There was x equals -2, there was x equals 0, and there was x equals 1. Because again, the slope is positive, negative, positive, negative. So every time it changes sign. Question C. We are defining a new function h here, which is a little bit weird compared to an accumulation function, but it's still the same idea. So h of x is defined as the integral from x to 3 of f of t dt. Find all values of x in the closed interval from -4 to 3 for which h of x equals 0. How can we interpret h of x? H of x is the area under the graph of f from x to 3. So if I want h of x to be 0, I can formulate the question like this. Where do I have to start if I want the signed area between that place and 3 to be equal to 0? Somehow when I read this question, the first value that I guessed was -1. I felt like if I'm starting at -1 and I go to 3, everything cancels out. So we can look at this again on this graph. If I go from -1, 0, now I'm at 1, and then it continues. Let's start again. If I start at -1, 0, 1, and then 2 and 3, we can see that the area that is below the graph is compensated by the area above the graph, so I would know this value x equals -1 is an answer to the question. But there are more values like that, and in fact if you already guessed, or if it was your first guess, that x equals 1 is also an answer, well done. For some reason, for me, x equals -1 came first, but if you start at x equals 1 and you integrate from 1 to 3, then we see that these two triangles are really the same, they have the same area, so the integral would be 0. Now there is one more possibility, there is one more value of x for which the integral from x to 3 is going to be 0, and that's so obvious we tend to forget it, but don't. The answer is x equals 3. When you integrate from 3 to 3, clearly there is no area. Question D. For the function h that we just defined, find all intervals on which h is decreasing. Explain your reasoning. So let's think about it without really using calculus first. If I have x equals -4, that means my function h is the signed area, or it's the integral from -4 all the way to 3. if I look at my graph, I have a little bit of area above the x-axis here, which will contribute a positive value, but I have this huge area here, which will give a negative value to my integral. So I wrote it like that. If x equals -4, the negative area is huge because of this whole place here, which will give me a negative number. If x equals -3, the negative area isn't as big, since I'm starting at x equals -3, and I'm integrating from here all the way to x equals 3. The negative part is slightly smaller, so h of x has increased. H of x was very negative at -4. Now at -3, it's a little bit less negative. And as I keep on going, if I choose x further here, it's going to continue to increase, because I have less and less negative area. If x equals 0, what does it mean? I'm integrating from x equals 0 to x equals 3. I actually now have mostly positive area. I have all of this, and I only have a little triangle here of negative area. So h of x is going to now be positive. After that, though, if I choose x further than 0, like at 0.2, 0.5, 0.8, I'm starting to remove the positive. So h of x is going to start to decrease. From x equals 0 to x equals 2, I'm losing the positive area, so h of x decreases. This was kind of an intuitive explanation. It was twisted and difficult to understand, but hopefully if you can make sense of it, that's great. This kind of explanation would not be good enough for AP Calculus, so even though we found the answer, it's from x equals 0 to 2, I'm going to redo question D with more AP Calc style answers. So h of x is defined as the integral from x to 3 of f of t dt, which, by using the properties of integral, I can switch the limits. It's the integral from 3 to x, and I have to add a negative sign. So the derivative, h prime of x, I still have the negative sign. It's d dx of the integral. Once again, just like before, I can check my three conditions. I have a constant here, I have the variable x up here, and it corresponds to the variable here. So my d dx and my integral can cancel out, and I can write f of x. So negative stays, and I discover that h prime of x is actually equal to negative f of x. So this is the slope of h. When is the slope of h going to decrease? Well, sorry, when is h going to decrease? It decreases when h prime is negative. That's by definition of the derivative. H is decreasing when the derivative is negative. And if you look at that, h prime equals negative f, that means h prime is negative when f is positive. And when is f positive? If I look at this graph, f is positive only here. That's the only time when it's above the x-axis. So that is true on the interval 0, 2. So writing these three sentences or similar sentences is essential to earn full credit. So if you want to look at the worked solution from AP and the breakdown of points, you can have a look at this later if you pause. If you are interested in practicing what we saw on the other example that I showed during this presentation, you can do it, and here is an extra example that you can also do that has similar questions, and I also have the answers. This was the worked solutions I found on ilearnmath.net, and for the last FRQ that I just showed a second ago, this one, the answers with the point breakdown is here. So you can pause on the screen when you want to practice. Thank you for listening.